Here we are, Math 3, 2.3. So, first thing we're going to do is expand these logarithmic expressions. So remember, we have those three rules. We have the product rule, which tells us that if we take the log base b of two or more numbers or letters that are multiplied, that's equal to all of those split up with a log of the same base and added together. Okay. We also have the quotient rule, which is like the multiplication rule, where we go the log base b of x divided by y. Same idea, we give each of the variables or numbers their own log, and we subtract them. Okay, and then finally we have the power rule, where if we take the log base b of a number raised to a power, that is equal to that power times the log base b of the number. Okay, so we're going to use a combination of all of these to help us with this. Now these first couple are pretty simple. So this first one we have log base 5 of 7 times x. So we're going to use the product rule. So we split it up and go log base 5 of 7 plus log base 5 of x, and that's it. Okay, number 2, same idea, 10 times a, so I go log base 5 of 10 times log base 5 of a. Oops, plus, not times, because they were multiplied, and we put a plus. Now on number 3, we have log base 5 of 5 divided by b, so now we're using the quotient rule. We go log base 5 of 5 minus log base 5 of b. We should remember that one of the rules we've discovered was that when those are the same, that's equal to 1. So really I could change that to 1 minus log base 5 of b if I really wanted to. But that's really not what we're checking right now. Number 4, same idea. So log base 5 of d minus log base 5 of 4. So that's all we're doing is expanding them, simplifying, in other words, as best we can. Okay, so number 5, now we're using that power rule. So with the power rule, our power here jumps down in front, so we have 3 times log base 6 of x. Okay, now number 6, we're starting to combine some rules. So first I have the power rule, so that comes down and becomes 4 times log base 2 of 7 times x. Then we split it up, and we get 4 times log base 2 of 7 plus 4 times log base 2 of x. So that 4 splits up with both of them. Okay. Number 7, now that squared is only with the x. So this time, first I'd want to split them up. Log base 5 of 9 plus log base 5 of x squared. Then I apply the power rule. So I get log base 5 of 9 plus that 2 gets pulled down in front. 2 times log base 5 of x. Okay, now number 8 is really tricky. And to figure out number 8, we have to realize that the square root is actually an exponent of 1/2. So it's really the power rule. So we bring that down and we get 1/2 times log base 3 of w. And that's what we get for that one. Alright, now if we look at number 9, okay, now we're going to apply a bunch of different rules. First thing I should probably notice is that we've got a division rule here. Okay, now this x squared minus 4, we can't really separate that. Okay, however, from last year, what you should recognize is that it's a difference of squares. 4 is really like 2 squared. And the difference of squares can be factored out, right? 2x minus 2 times x plus 2. So that multiplication, we can then separate them. So we'd start out and we'd have log base 2 of x minus 2 plus log base 2 of x plus 2. Then that division would make it give us a minus log base 2 of x cubed, which then that power rule comes in get that 3 jumps down, and we get minus 3 times log base 2 of x. Okay, now we can't separate these ones because it only works when we have multiplication or division in there. So that's as simple as 9 will get. Okay, so they can get pretty complex on these ones, can't they? So looking at 10, so I've got an x squared up here minus these guys who are times. So the quotient rule says I'm going to have log base 2 of x squared minus these guys, log base 2 of y to the 5th times w cubed. Now these ones I can use the product rule for, so I get log base 2 of x squared minus log base 2 of y to the 5th plus log base 2 of w cubed. Okay. Now we can apply the power rule and bring all these powers down in front, and we get log base 2, or 2 times log base 2 of x minus 5 times log base 2 of y plus 3 times log base 2 of w. And that's as simple as we can get it. And I know that doesn't look much more simple, but for what we want to use with this, it is. Okay? So now 11. So we've got x, y, and z, so we use the product rule on all three. So log base 5 of x plus log base 5 of y plus log base 5 of z. Then w here is a division, so we go minus log base 5 of w. So that one wasn't too bad. Now on 12, we're going to have to do a lot of work with this one. So first of all, I should realize that's 9 times x to the 1/2, because a square root is a 1/2 power. So I'd go log base 9, or log base 5 of 9, plus, because we used the product rule, because it's multiply, log base 5 of x to the 1/2. Then we use the quotient rule, so we subtract log base 5 of y cubed. Now we can use the power rule to bring down these powers. We get log base 5 of 9 plus 1/2 times log base 5 of x minus 3 times log base 5 of y. And there we go with that one. Okay, now the last ones, we're just rewriting them. And remember, to go from exponential, we have b to the x equals y. To change it to logarithmic, we just go log base b of y equals x. So my b here is 2, so I go log base 2 of my y would be 512 of 512 equals my exponent 9. Number 14, I have 10 to the negative 2 equals 0.01. So I go log base 10, because that's my base, of 0.01, because that's my y, equals my exponent negative 2. And if you wanted to, you could type this into a calculator and double check your work. Okay, and 15. So my base is 2/3, so I go log base 2/3 of 3/2 equals -1. Alright, now if we're going exponential to exponential form from logarithmic, we just work backwards. So this becomes the base, what it's equal to is the exponent, and what's the input becomes the output. So base of 4, so I go 4 to the power of 1/2 equals 2. 17, my base, 1/3, so I go 1/3 to the -1 equals 3. And finally, we go base, so 2/5 of the exponent, 3 equals the input, 8 over 125. And there we go, guys. That's all there is to it. We're good.